So this is an FRQ from a few years ago. And we have a large company having two shifts, a night and a day shift, that produced parts that must meet the same specifications. The manager of the company believes there is a difference in the proportion of parts produced within specification by the two shifts. Most of you are already thinking, oh, it's a too simple z-test. Well, let's read everything. To investigate this belief, random samples of parts that were produced on each of these shifts were selected. For the day shift, 188 out of 200 selected parts met specifications. For the night shift, 180 out of 200 selected parts met specifications. So in other words, for the day shift, it was 94%. For the night shift, it was 90%. Use a 96% confidence interval. Okay, so we're doing a confidence interval, a two proportion Z interval. So we're going to do a 96% confidence interval to estimate the difference in the proportions of parts produced within specifications by the two shifts. So here we go, creating a confidence interval. So the first thing I'm going to do is I'm going to define what we're talking about. In this case, it's the p hats of both. So the p hat sub D is the proportion of day shift parts that met specifications, and p hat n is the proportion of night shift parts that meet specifications. Then I'm going to define p hat of D and q hat of D, which is, as I've already said, 0.94 and 0.06, and of n, the night shift, or 90% and 10%. And it told us they were random samples of both shifts, and we know that each shift is independent of the other. We know that 200 is less than 10% of the product made from either shift of the parts. Then I do the success failures of each. NPD is 188 and QD is 12, both greater than or equal to 10. And then that's for the day shift, and for the night shift, it's 180 and 20, and both are greater than or equal to 10. So I'm going to do a two proportion Z interval, a two proportion Z interval. And so from that, I then know that my confidence interval, which is also, excuse me, on our formula page, our confidence interval is the statistic, which in this case, it's the difference between P1 and P2, or the proportion of daytime minus the proportion of the nighttime, plus or minus our critical value, which we're going to find it's 96%. We hadn't talked about that, but I'm going to show you how to find that. And then the standard error. Okay, well, let's go there first. How do we find the standard error? Standard error for two populations is P hat, Q hat divided by their sum, which both of these are 200, and P hat, Q hat of the second one. So this is nighttime, this is daytime, both over 200. And that's going to be our new standard error. And so I write that. Standard error is that. So P hat of D minus P hat of N plus or minus Z star. Well, what is Z star? Well, to find Z star, what I'm going to do the fastest way, and I've discussed this with you, is to go to the T table. This is in our, this will be there on the test for you. We'll go to the T distribution. And for the T distribution, even though it's not exactly normal, but we've discussed as those degrees of freedom approach infinity, like that calculus reference there, as the degrees of freedom reach infinity, then our confidence levels down here on the bottom give us our Z-score and a T-score that are equivalent. So for a 96%, my Z-star is 2.054. See, there's 95% is 1.96, 90% 1.645, 99 is 2.576, numbers we've seen before. 96% is 2.054, so that's my Z-star. So then notice I've already got the interval, but we'll go through the steps on the calculator here. Now, of course, you have to turn it on. So I'll go stat, over to test. Now, notice I have two sample Z interval down here. I have two sample test, but I don't want that. But let me go a little bit farther down. I have my two proportion Z interval down here. Okay, because this is going to be easier because it's already proportions and set up. Did I call this sample up here? No, I call it proportions. That's what we're trying to find. So there's our 2 proportions of the interval. So I put in my x sub 1, which was 188 over 200. My night shift was 180 out of 200. And my confidence interval is 0.96. Whoops, sorry, you can't see that because of the lights there. There we go. Is that a little bit better, I hope? So then we put those numbers in and we calculate. And sure enough, there's our p hat and q hat that it gave us. And there is our interval, negative 0.0156 and a positive 0.0956. And some of you are already thinking, one's negative, one's positive. Remember, put your lower number first. So the question is, what is our conclusion? I haven't written that yet because I wanted to write it out here for you. So here we go. It's a 96% confidence interval. We, or me, or I don't care how you're doing it, we are 96% confident. Okay, and here's where a little bit of a dilemma comes in. I have people that gave me all kinds of answers on these. So I want us to go back to the original question, the original part up here. Use a 96% confidence interval to estimate the difference in the proportion of parts produced within specifications by the 2 shifts. Okay, we are 96% confident. The difference in the proportions of parts produced within specifications by the 2 shifts. That's what we're writing next. We are 96% confident the difference, because that's what we were finding. In the proportions of parts produced, a lot of P's here, within specifications not of, by the 2 shifts, put the F in there, lies between, falls between, is in the interval. Okay, and I think that is good enough for what we want to do. But then part B comes up to us. Part B gets a little bit here crowded. Based only on the confidence interval. Okay, based only on our confidence interval, do you think that the difference in the proportion of parts produced within specifications by the 2 shifts is significantly different from 0? And to justify your answer. Well, this is fairly simple. We're looking at our parts here. There's our interval. So for part B, this is what I'm going to, this is my answer for that thought. Since the interval, let me move up just a little bit, sorry. The interval contains 0, then it is possible. Sorry, my throat is very dry. Let me grab me a little bit of a drink here. Sorry, that was a lot of drink. Then it is possible that 0 may be the difference between the two shifts. Okay, so now we have most people say, oh, that's enough. No, that's not enough. We got to go one more thing because here it is. The manager of the company believes there is a difference. So we need to say there is not evidence to support the manager's claim. Sorry. Since the interval contains zero, then it is possible that zero may be the difference between the two shifts. There's not enough evidence to support the manager's claim. Okay, that wasn't too difficult, was it? Took us a little over 11 minutes, but hopefully it's understandable.